Hello everyone, I'm Yassine. I work as a postdoc student at Mines Paris, and I will present to you some topics on which I work around open dataset and how to leverage them for building energy consumption estimation. So starting in 2016, a law was introduced in France that let's say, encourage the administration to publish their datasets that are relevant for energy transition as open datasets. And for the case of studying building energy consumption, we can think about three, let's say, subjects of interest that are for which open datasets are provided. First, a description of the building stock. So you have some dataset provided by IGN on building geometries and attributes. You have the census at the dwelling level that also provides information on dwelling and their characteristics. And then you have the dataset on energy performance certificates. You also have open data on the energy demand at the district level and by sector. And you have datasets on distribution networks by Enedis and GRDF mainly. With this wide array of datasets, a lot of opportunities can arise when there is a complementarity in the dataset. So what I mean by complementarity is that the dataset overlap on some attributes, so that allows the matching of several datasets. Complementarity also implies that the datasets do not contradict each other. I will come back into this aspect later in detail. And also, to leverage the matching of the dataset, you need some difference between the datasets. So it can be difference on the scale of the dataset, its exhaustivity, or the domain that are covered. When these conditions are present, you can leverage the combination of various datasets to bring new insights. So I give, for example, one example of this that consists in merging the dwelling level census data with the energy performance certificate data to obtain the performance certificate for the complete building stock. So here you have the link to the open source code. So the code in itself is open source, and all the data that is used as input is open data. So you can reproduce this integrally using this open dataset, open code. And also, if you are interested in Python and performance treatment of large dataset, this open source code leverage the new Polars library. So if you want some ideas of how to use this library, this is a good place to start. Of course, not everything is rosy, and you can have a lot of challenges, and mainly, from my point of view, these challenges stem from the contradictions that can appear between the dataset that you are trying to merge. And so this condition arises when you have, of course, overlap on some attributes that allow matching, but the datasets are both exhaustive on comparable scales. For example, a district scales, you have two datasets that give you two different information for the same subject. So for example, here I give an idea about the BD Topo dataset that gives the year of construction for every building, and you have also the dwelling census dataset that gives the year of construction for every building. You can compare them on the same scale, which is the IRIS in this case, and see that in many situations you will not have the same distribution of construction year between the two databases. So before matching them, you have to have a methodology that allows them to be compared. Last message that I wanted to give is, but I probably don't need to convince a lot of people here, but models, even if we have a large sample of dataset, models are still needed, and I will say 3 points mainly. They are needed to reconcile contradictory data, assist in selecting a realistic value for missing data, and forecast, of course, the impact of energy transition policies. Last slide, I give an example of such an idea. You also have the open source code here at the address that you can see, where we mix all of these data sets to provide an energy estimation consumption for all the buildings in all the cities in France who are not connected to the gas network. And starting from this consumption, we model what would happen if we electrify the heating on all of these buildings and show the impact in terms either of energy consumption increase and peak consumption increase. You have the code right here. Thank you very much.